Let's talk about arrays in Swift. Arrays are a frozen structure in Swift. They're kind of a collection, not kind of, they are a collection type, and they can contain pretty much anything. And they can be constructed in different ways, they can be used in different ways, and since they're structures, it means that they have mutating functions to let you mutate their contents. That means, for instance, if you have an array, which is in theory a doubly linked list, if you have an array that is structured as I'm showing here in this playground, a let array of an array of int is an empty array here, in this case on line 3. In this case, this is a let array, which means you cannot call any mutating functions on it. So because you cannot mutate let instance of a struct. And we will get into all of this, but I'm just trying to say that an array is defined inside Swift as a frozen structure, basically, just like many other structures like int and string. So they're not classes. That's what I'm trying to say. Well, let's just dive right into it. An array is a two-dimensional data structure in Swift, just like it is in many other programming languages, and it can be constructed in so many different ways. One of the simplest ways to do that is with opening a square bracket, and then you can print this contents, for instance. And you can see we'll get 1, 2, 3 here, and I'll just get rid of this area so we can just focus on the right hand side. Maybe a little bit bigger font as well. And if you'll see here, there's a function called append, and I can say add the value of 2 or 20 to this, but we'll get a compilation error here, and it says that this is a mutating function on an immutable let instance of array. And using the fix, it will turn this variable, turn this let into a var. So you can now append to it, and then if you print this array, you will see you'll get 1, 2, 3, and 20. Basically, that's the simplest way of creating an array. If you have an empty array, but you know the data type, then you will need to specify that at the time of creation, because if you say let array, then you will see here now that Swift has no idea what kind of data type this is going to be, and that's quite correct. So you need to give Swift some instructions as to what type of data this array is going to contain. Now you can say int, for instance. Here you can say this is an array of int and is empty, or alternatively you can say this is an array of int, just like this, and this will work as well. So it will produce the same result. I don't know at compile time which one is faster. Honestly, I haven't looked at the compile times of array in its construction state, so I cannot really give you a well opinionated detail here as to which one you should use, but I think the most important thing is to stick to one convention for your empty arrays and just continue with that convention throughout the source code for that project that you're working on. I think that is typically a good thing to do. So that's for empty arrays. Well, arrays don't always have to be known in the beginning what their contents are going to be. So you may say this is an empty array of integer, and then you can start adding items to it using the append function. As I said, an array doesn't necessarily have to be of a specific type. You can also say this is an array of anything. And array append, you can see I can append 10 to it. I can append the string foobar, and I can append even the array itself to that array. And you will see here that after the first append invocation, then the array is going to contain the value of 10 as an integer, and then foobar as a string, and then it's going to add itself to itself, which is going to say 10 foobar and then array inside the array. In order to extract these items, you use something called a subscript in Swift, and you say just array item 0, which means the first item. And there's a shorthand for this as well, is using first, which is an optional of t. In this case, t is any, so it will be optional of any, as you can see here. And there's also a shorthand for the last item in the array, and that's last. And this will also be an optional of t, in this case, any. You can even look at their definitions, and you can see it's just an optional of element, and element is defined on the array itself. If we can go to, if I say this is an array of any, and we go to the definition of array, you can see element is a generic data type defined for this frozen public struct. So these are for first and last, but as I was saying, you can also use a direct index of an item in the array to refer to that item. So if I, for instance, want to get foo bar, then I can say array index 1, because indexes in arrays in Swift, as they are in almost every other programming language that I know about, or every other programming language that I know about. Maybe they're in some other programming languages, they're not like this, but arrays in Swift have 0 indexes for their elements, meaning that the first item in the array has the index of 0, second item has the index of 1, and so on and so forth. And the last item in the array has the index of array's length minus 1, since array indexes are 0 based. So that means array last is equivalent to array's item of array length, or count, I think, minus 1. And we can run this and you can see the results for yourself. It's going to return the array itself, since the last item in the array is the array itself. Maybe I should comment this out so it becomes a bit clearer that foo bar is the last item. You can see it's equivalent. And you can press Command Option on Mac and then press this square bracket here and go to the definition of this function. You'll see as a subscript. Takes an index. So that's for accessing items in the array. You can do that with first, last, and then you can use square brackets to actually go to a specific index of an item in the array. Now, this is a little bit tricky using the subscript, because as you can see, the return value of this function, if you go to the subscript, is an element. And I think is documented here that that if this index doesn't exist, must be greater than or equal to start index and less than end index. I find it a little bit strange though, since Swift is a strongly typed language, and I find it strange though, since Swift is a strongly typed language, and subscripting could potentially lead to a crash without you being even able to catch the exception. So you see this is not a throwing function. This is not a throwing subscript, meaning that if you provide an index inside this array, and I'm sorry about this, I'll just go into do not disturb. I just remember I wasn't on do not disturb. Which means that if you accidentally try to access an item in the array that doesn't exist, so an index of 2, which means the third item, you'll see that your program crashes. So this is a horrible experience, in my opinion, because you cannot catch this in any way. This is not like an exception that you can catch. It's literally a halt in the program. So be very careful with these constant subscript indexes. Typically a good way of going through an array's items, if you want to iterate through them, is with the for. You can say for value in array, and then you can print the value. We can run this, and you see it's iterated 2 times, and then it prints these values 10 and foo bar. We can see foo bar here, and then foo bar. And why don't we get 10? Well, we're getting 10 here, so that's quite obvious. So using the for x in iterable syntax, you can iterate through all the items in your array, because an array in Swift is something that we call iterable, just like it is in Python, Rust, JavaScript. It's exactly the same format. In Dart, it is literally the same format, except for Dart, where you have to say, for instance, final value in array with parentheses, but otherwise it's the same format in pretty much every language. So this is for iteration. There's another way to iterate through items in an array in Swift, and that is using the for each function, and that is for each, and you get a body, and in this body you see there's a callback that says I'll give you the items in the array and you can do something with them. So I'll say, okay, I really like to type the exact type of objects that are in my callbacks. I've noticed in bigger projects, me and my colleagues have noticed that if we don't specify types and let the Swift compiler detect these types for us, of course it is very clean, but first of all, it's very unclear what this data type is by looking at this in an isolated space. For instance, if the code looked like this, you wouldn't know what this actually is unless you go to the array and then get its type to see, oh, this is an any, so any object in it is also of type any. So first of all, we believe, or I strongly myself believe, that specifying the type is important in these functions. First, because it makes the code very clear what it's doing and what the type of the items is, and any programmer looking at it will understand this is a value of type any. Secondly, we've noticed that it speeds up the compile times. So if you have a huge code base and everywhere you're using generics and you're asking the compiler to determine the types of all these items that are passed into closures with no data type specified, the compiler is going to have to do a lot more work. And that usually means longer compile time. So it's completely up to you and your team, but we've decided in our team to not let the compiler make these decisions and specify the types ourselves. So it's completely up to you. In this case, I'm going to specify the type, and I can, for instance, say print value. And I'm going to run this, and you'll see the exact same result as we saw before. So that's for each. I'll remove these. There's another really important function in array, which is used a lot, and that is map. The map function takes in a closure that for input of this closure, it provides you with the items iterated through this array, and as the output expects you to return a t, as you can see here, and the result of this map will in its turn be, as you can see, an array of t. In other words, if you provide a closure to the map function for every item returned from this function, that item will be placed inside a temporary array, and the entire array will then eventually be returned from map. So it's a lot easier if I change the data type of this array to int. I say this is an int array, and then append 10, and then maybe append 30 as well, and append 50, just like that. And then I'll map this. You'll see the Swift compiler understands every item is of type int, and then I can return anything. Okay, I'll say value is int, and I'm going to return a string. And again, this is something very related to the for each function. I really recommend that you specify your return types and input types. I know it looks slick to remove them. You may think, oh, look what I can do. But we've really realized that in huge code bases, this is a massive time consumer, because first of all, it's difficult to read and understand. Not that people are going to be like, oh my God, what is this code doing? Not like that. It's confusing just to look at it at first. And then every programmer has to be, okay, this is an array of integers, so every item is an integer. And also try to specify your return values. I highly recommend it, because although the Swift compiler is intelligent enough, so it's intelligent enough to understand, okay, you're returning a string from here, so you don't have to specify this. But if I write a code like this, literally specifying nothing in there, it will also work. It produces the exact same results as you'll see here. You see, the array of integers became an array of strings. It works. And you can even remove this. I know a lot of programmers will, oh, look how slick I am. Beautiful. I found this code really slick many years ago, but I don't find it slick anymore. Simply because working in large projects with other people, it's more important to make the compile time, to improve the compile time and also improve the readability of the code than it is to just be slick. Something like this may work, but if you're doing more like complicated computations in your closures, I think it's better to specify the return type. So back to map. Here in the map function, what you can do is to get every item in the array and then produce something else. And then the result will be an array of this thing that you're producing here. So that's what map does. And also you can, there's another functionality in arrays, which is important, so I'll name it, is filter. What filter does is very similar to map, is in that it provides you with items in your array, and for every item you're required to return true or false. And for items returned, for items that you produce true for from this function, they will be collected in a special array and finally returned from filter. In a not so computer science way, it asks you to cherry pick items that you want from this array, meaning that if you, for instance, are interested in values in this array whose value is higher than 20, for instance 30 and 50, then you can go to your filter and say, okay, this is the value, and I'm supposed to say whether it should be included with a true or not included with a false. And in here I'll say, okay, as long as the value is more than 20, it should be true. And if I run this code, you can see 30 and 50 are going to be included in the array. So that's for filter. We also looked at count, and count is simply going to just return the number of elements in your array. And as you can do append, you can also remove. You can see by removing, you have so many different options and ways to remove items from an array. The first one is remove at. You can say, okay, remove the object at index 1, which means remove the second object, in this case 30. And if you run this, it's also returning the value that it's removed. You can see int. So I think this function, now I'm guessing, I think this function is marked with discardable result because it's not nagging. Somehow the Swift compiler is not nagging that I'm not using the return value of this function. And that's pretty interesting because it's not even marked with discardable result. So I don't really know what kind of a black magic the Swift team has done with this function. Because usually if you have a function and you say func blah returns a string, and then you say foobar, and then you call this function, usually the Swift compiler says, oh, ooh, you're not using the return value of this. But maybe it's because I'm in a playground. Maybe. I don't know. Since the playground is consuming the return value of every function with a return value and printing its results here. Probably. But anyway, back to remove. You can provide the index of the object to remove. And there are other functions, for instance, remove last, remove first, and remove last number of items. There's also a way for you to extract a range of values from an array. For instance, you can say, if I create an array here, a little bit easier, and say 10, 20, 30, 40, and 50, if I, for instance, want to extract the third item all the way to the fifth item, I can say, and I'll change this to let because I'm not planning to change its value. I'm going to say third to fifth items. I can say array. I start with the index of the third item, which is 2, and then I'll say all the way to the fifth item. Oh, I think there's another dot here. And oh, fatal error, array index is out of range. Oh, fifth item's index is 4. like this. So 30, 40, and 50. So third item to the fifth item. But you don't, since in this case, I want to read the third item all the way to the end's index may change in the future. It may be another item added here. Now this code is not going to work so well if my purpose was to read from the third item, for instance, to the end of the array. In that case, you can just say to ... and you'll see here that it will read from the third item all the way down to the first item. To be honest with you, I'm not sure if you can do the same thing but in reverse and say like the first item or the fifth item and anything before it. Maybe can we do this? I haven't tried this, so yeah, it works. This is really nice. Cool. And these are, I think these are just like operators of some sort. Let's see how they're defined. Static func. Okay, it returns a partial range through. And then there's a subscript that allows that, of course. Where is it? Partial. Oh, Jesus. Partial range through. Okay. Partial range from is available. Well, anyway, there's a subscript that handles this format for us. So, and to be honest with you, I think these are the most used functionalities that you're gonna need inside your arrays. Filter, map, first, last, count, and you may also use reduce. So maybe we should talk about it. Let's talk about reduce as well before we wrap it up. As you can see, I'm doing this video really ad hoc. I'm just really going through all the functions of array that I usually use. So I hope that's okay. Reduce is a function that works in a way that you provide it with a seed with a value of any type. In here, I can just say foo, and it gives you the ability for every item in the array to produce a new item of any data type, and it will then, the next time during the iteration, you will get the value that you produced previously and a new item in the array, and you will have to do your calculation and say, okay, what do I want to do with these values? For instance, in this case, I'm saying I'm starting with the string foo, and I know I'm going to produce a string because I'm starting with a string. This is what I'm going to produce, a string. So in here, I'll say result is a string, and the item I'm going to get in the array is an integer. I'm going to reduce the font a little bit so that you can see the entire. So the item is of type integer, but I'm going to produce a string at the end, right? Because we start with the foo. The first time the iteration happens, the foo comes in here as the result, and it will extract the first item in the array, which is 10, and says, okay, here's the string you gave me. Here's 10. You said you want to produce a string. How do you want to produce a string? Then I'm going to say, okay, I'm going to produce a string by appending and concatenating result with a dash to the string version of this item. And that's it. And when you run this, you'll see what happens. It says foo dash 10 dash 20 dash 30, 40, 50, and so on and so forth. So reduce is kind of like fold in Dart. And I think some other languages also have reduce. Basically, most programming languages have reduced when it comes to arrays or lists, as they're called in some other languages. So anyways, I don't want to babble on. These are the main functions that I personally use on arrays in Swift. I hope you like them, and please go ahead and experiment with arrays in Swift as much as you can, and let me know if you have any questions. Have a great day.